So let's start our lesson on slope-intercept form of an equation of a line by reviewing what we know about lines so far. Most important, we know a lot about slope. We've really developed some slope concepts in the last few weeks, namely that slope is defined, or first it's represented by the letter M, and it's actually defined as a change in y over the change in x. So this is delta y being just a shorthand way of saying change in y values over the change in x values. So the slope is essentially a ratio of rise over run. And we have a formula to find the slope. If we know 2 points, we can use the x and y ordinates for each point, y2 minus y1 over x2 minus x1. Then what do we know about the slope? After we've worked with the slope, we see that there are 4 different types. One, there's a positive. So a slope can be positive, which means that the slope points into the first quadrant. So the arrow or the line tilts in a way that the highest part of the line is in the first quadrant. Slope could also be negative, which means that the highest point of the line points toward the second quadrant. So it points up to the left. A slope can also be 0, meaning M equals 0, and that's always a horizontal line. And then the slope could be undefined, UDF, being the shorthand for undefined, and that's a vertical slope. We also know that lines are made up of infinite points all arranged in a straight line. So we tend to like to use lattice points, meaning they intersect at an x and a y integer value, but points in between the x and y integers also make up the line. But if we look at this line, we can see that it has many points at lattice points, and that we have a label for these called a coordinate, where we start. It's an ordered pair, meaning the x ordinate goes first. So this point would be at x equals -1, -2, -3, -4, and y equals 1, 2, 3, 4, 5, 6. Down to this point, x equals -3, y equals 4, x equals -2, y equals 2, x equals -1, y equals 0. We call this point the x-intercept. And what that means is the line intercepts the x-axis at that point. If I keep going with my labels, the next point I have is x equals 0, y equals -2, and you can see that similar to the x-intercept, this point crosses or intercepts the y-axis. So we call this point the y-intercept. These are very important points. They're special points, partly because they're easy to find, as you'll see in a little while, but you need to be able to refer to each of these points as of a line as the x-intercept or the y-intercept. They're very important. So the slope is a very important part of a line, so is the x-intercept, and so is the y-intercept. And I suppose I might as well continue labeling my points. So x equals -1, x equals +1. Put back all my work. X equals +1, y equals -4. And then this last one, x equals 2, y equals -6. So I have a whole string of points that can all be labeled as having integers for x and y ordinates. All the points in between are just as good, but we like to work with the integer values called lattice points. That lattice point being wherever a line intersects with a lattice with a y and an x values that are integers. We also have methods for graphing points if we're given, for example, an equation. So I could say graph the line y equals minus 2x minus 2. We just make a table with a domain, which is the independent variable, and a range, which is the dependent variable. And what that means is if I decide that I'm going to plot points on the graph of minus 2x minus 2, I'm free to choose any input for x that I like. I like integers, again, just like when I'm graphing or labeling points. I prefer not to label a bunch of halfway. Half is okay, I guess, but I certainly don't want to label really odd decimal values. So I'm going to choose points that I like. I think I'll start with, let's start with x equals 2. And so y equals negative 2 times 2 minus 2. Negative 2 times 2 is negative 4 minus 2 is a minus 6. And then I could choose a 1. Y equals negative 2 times 1 minus 2, so that equals negative 4. Then if I choose 0, y equals negative 2 times 0 minus 2, that equals minus 2. I don't know if you see the pattern, but I'm actually getting, when I plug 2 into the equation, I get negative 6. When I plug 1 in, I get negative 4. When I plug in 0, I get negative 2. If I keep going and choose x equals negative 1, y equals negative 2 times negative 1 minus 2 equals 0, which is the next ordinate, and I would get the same values all the way through. And the reason for that is that I've written the equation of this line in order to calculate my coordinates. So this is a pretty comprehensive view of where we are at this stage in the game in graphing lines. And I think you would also agree that this is a fairly large amount of work, plotting a bunch of points. In fact, I didn't want to plot the extra 3 points just because this is a lot of work. It's important to understand how I get the coordinates from a graph, or once I have the graph, to be able to describe it as having, in this case, a negative slope, because the arrow points up into the second quadrant, so a negative slope, and that the slope is defined as rise over run using any of these forms. I've introduced something new, the x-intercept, wherever your line crosses the x-axis, and the y-intercept wherever your line crosses the y-axis. Both big concepts. So let's look at taking some of the work out of graphing lines. That's what algebra really is all about. I'm always surprised when students tell me that they hate graphing after they've been in Algebra 1, primarily because we've spent a whole bunch of time making graphing just so much easier. So let's see if I can prove to you that this is easier if you use algebra to graph a line rather than basic pre-algebra or pre-algebra skills. So let's say I want to graph the line, and we have done this in class already. Suppose I want to graph the line 3x plus 2y equals 12. All right, so first thing you think to do at this stage of the game, before I introduce easier concepts, is to get a bunch of ordered pairs, so that if you can plot a bunch of ordered pairs, then you can string them up to make a line. So in this case, I would just make a table so that I could get a set of values, and I would put a place to put in my domain and my range, and a place to put in my equation. But remember, the equation that I want is in the form of y equals. So y equals is not what I have. I was given something that doesn't have the y variable off by itself, but that's okay. That's just called solving for y. We know how to do that. I want to isolate the y variable, which means I'm going to subtract 3x from both sides. So I get 2y equals, subtract 3x from this side, it disappears, subtract 3x from this side, and I get a minus 3x plus 12. And now I can divide through by this 2. So 2y divided by 2 just equals y. And negative 3x divided by 2 is negative 3 halves x. Plus 12 divided by 2 is 6. So now I have an equation that I can use, minus 3 halves x plus 6. So let's start choosing some x values. Now, the instinct is to choose all nice positive x values, but really we should kind of spread across the positive and negative. We want to choose values on the right hand side of 0 and on the left hand side of 0. So what do you say we choose negative 2? Y equals negative 3 halves times negative 2 plus 6. Well, the halves cancel. The two negatives is a positive. 3 plus 6, is 9. Negative 1, y equals negative 3 halves times negative 1. All that does is make 3 halves positive. Plus, well, 6 is exactly the same thing as 12 halves. So I have 3 halves plus 12 halves is 15 halves. 0, y equals negative 3 halves times 0 plus, well, this time I can just use 6 because I don't have to, since this fraction is going to zero out, I just end up with a 6. I'm going to choose 1. Y equals negative 3 halves times 1 plus, this time I'm going to use 12 halves again. And I get negative 3 halves plus 12 halves is the same as 9 halves. And now choose 2. Y equals negative 3 halves times 2 plus, well, the 2's are going to cancel, negative 3 plus 6 equals 3. So now in order to graph this, I merely need to plot the ordered pairs. So this first input-output pair is negative 2 and 9. So I'm going to call this negative 2, but I don't have 9 on the positive y-axis, so I'm going to call each interval 2. So I have 2, 4, 6, 8. This would be 9. And so negative 2, 9 is a point on my graph. Negative 1, 15 halves, I don't really want to deal with that, right? We like to graph with lattice points. So I did all of this work and I'm not even going to use it. 0 and 6, x equals 0, y equals 2, 4, 6. Notice I have a very critical point here. This is the y-intercept. Because it's where my line is going to cross the x-axis. Again, I don't really want to plot this next to last point because I get 9 halves as a y-ordinate and I don't want to deal with that. And then 2 and 3 is another lattice point. X equals 2 and y equals 3. So you can see that these points all line up to form a line. Whoop, where'd my point go? There it is. So if I want to graph this, notice I'm going to use all 3 points to line up my line, but I don't really need all 3 points. These 2 points would be enough to line up my entire graph where it lives. Similarly, these 2 points would be enough. I don't even need this extra point over here. I just need these 2 points. Or I could do without the middle point. So first thing to notice about graphing lines is that we only need 2 points. So you need 2 points to graph a line. The extra points are maybe helpful, but they're not necessary. 2 points to graph a line. You have to have at least 2 points, but you don't have to have more than 2 points because all of the points on that line are going to line straight up in a row, and so only 2 of them will give you the entire line. So that's convenient because now that I know I only need 2 points, it was certainly safe for me to not use this one and safe for me to not use this one, but I could have saved myself the time and not even used that one. So first time saver, you only need 2 points to graph a line. Now, I did graph these points. I'm going to pretend that I didn't graph the last point. Let's see if I can erase it without having things disappear again. Good. So the first point is labeled because I labeled it on the axes, -2 and -9, excuse me, and +9. That one's done. This one, I either have to label the y-intercept where it is on the y-axis, or I have to create a coordinate label, and I'm going to put 0, 6. So if you plot a point, you have to label it. That's another good reason for not plotting a whole bunch of points, because if you plot it, you have to tell me where it is, which means you have to do all of this work. We've eliminated all of this work, most of this work, and at this point we haven't had this work yet on this problem. So we've eliminated a fair amount of work, which is pretty nice if you ask me. Well, let's see if we can eliminate some more work. In fact, we totally can. Let's look at this line where I chose x to be 0 and I got 6 for y. But what did I get when I calculated that line? When I chose x to be 0 and I got 6 for y, that was my y-intercept. My y-intercept is always, always, always where x equals 0. So the y-intercept on any graph, and this is true no matter how far you go in mathematics, all the way through 17 levels of calculus, if you go that far, it doesn't exist, but if you did, anytime you want to know what the x-axis is or the x-intercept is, all you have to do is put in 0 for x, and it tells you. So now we've at least found an easy second point to find. So our second point, or our first point, anyway, an easy point to find is put 0 in for x, and then whatever that gives you is your x-intercept. So that's kind of nice. So one of them or I should say the easiest of them is the y-intercept, which I write as y-sept, at x equals 0. If you plug in 0 for x, it makes sense that the output is going to be someplace on the y-axis. You put in 0 for x, and wherever that line is going to cross the y-axis is what you get. That's cool. But now, notice what happened. When I put in 0, this whole first part of the equation disappeared. So really, when the equation is written in this form, not when it's written in that original form that we have, but when it's written like this, where we solve for y, this last number is our y-intercept. And I'm going to give you a little shorthand here. The y-intercept is at x equals 0, b equals the y-sept, or I should say it equals b. You don't know what b is yet necessarily, but I'm going to tell you in a minute. And so that's kind of an important thing. So we've taken a good amount of the work away already. Now, all we have the easiest point to find, which is this number here, and one more point. Well, what's the easiest way we know to find a point? We can certainly calculate to find any other point on the line, but don't we have something easier to do? We sure do. Look at this. If I start here at the y-intercept and I go up 3 and backward 2, then haven't I found the slope? The slope in this case was up from 6 to 9, rise, over, backward, run. So I can use the slope to find my second point. So 2 points to graph a line. The easiest one of them is the y-intercept, and the next one, find using the slope. That means I really don't have to do any of this work. I don't have to do this work because I know where it is, and I don't even have to do this work because I can use the slope in the equation to get my next point. The only question is, where the heck is the slope? Well, you can tell here on this one where I said rise 3, run backward 2, -3 halves, isn't that this number? It sure is. So if I can get the equation written in this form, regardless of how it's given to me, if I can convert it to this form, I can graph this line without any of this other work, with nothing else. So let's do a couple just to prove how easy it is. Let me give you some language to go with it, and you might have predicted it from the name of this lesson. Slope-intercept form is exactly what it sounds like. I have the y-intercept for one point, and I use the slope for the other point. I can find 2 points for the line if only my equation is written in slope-intercept form, which is y equals mx plus b. There's that b. Let's look at our lesson, or let's look at our previous example. Wasn't our slope the number right in front of the x? That's our m. And we're already used to using the letter m to represent slope. And wasn't our y-intercept the place where our graph crossed the y-axis? Wasn't that this second number back here? And that's our b. So let's graph a line real quick using now our slope-intercept form. Let's graph. I'm going to make one up. It's always a bad idea. If it's too bad, if it's too ugly, I'll erase it and you won't even know I did it, but let's see. Graph 3y plus 6 equals 2x. Okay, 3y plus 6 equals 2x. First thing I need to do is solve for y and hope I end up with an mx plus b form. So first let's solve for y. I'm going to subtract 6 from both sides. So 3y equals 2x minus 6. Now I'm going to divide both sides by 3, so I get y equals 2/3 x minus 6 divided by 3 is 2. Do I have the form I want? I have y equals, that's my slope, x, plus that's my b. Notice that b has a positive in the formula here, but here it's a negative. All that means is this is the same thing as y equals 2/3 x plus -2. It just means that my y-intercept, or my b, is -2. So let's graph it. Well, b is -2. We already decided that, so I'm going to graph it and I'm going to label it 0, -2. And that makes sense, right? Because if x is 0, y has to be the y-intercept. And now I've got a slope of 2/3. Just bounce it. 2/3 is +2, +3, so I'm going to bounce up 2, takes me to here, up 2, and then forward 3. 1, 2, 3. And I end up, well, I happen to end up at my x-axis. That's not necessarily always true, or excuse me, my x-intercept. That's not necessarily always true, but hey, I'll take what I can get. I don't have to figure out any more points, because once you have 2 points on a line, the line that connects them, or 2 points, the line that connects them is the line for that equation. Done. Let's do one more. Let's say -3y minus 2x equals -4. Okay, so first thing I want to do, I want to solve for y because I want to get it into slope-intercept form. So I'm going to say -3y equals, add 2x to both sides, so it disappears from this side and becomes 2x on this side, minus 4. Now I have to divide both sides by -3, which means it disappears here because -3 over -3 is a 1. So I get y equals -2/3 x, minus and a minus is a plus, 4/3. Okay, I'm not going to like this because it's fractions, but still, it's easier than having to do calculations. What if, imagine plugging in 0, 1, 2 numbers in here with 2 fractions. That's a lot of work, but I don't have to worry about that because I know that b The y-intercept is 4/3. So 1/3, excuse me, 3/3 and a little bit more is 4/3. That's my y-intercept. So now all I have to do is bounce my slope, which is 1, 2, up. So I have to go backward 3. 1, 2, 3. And so my point is right here. Now I could have bounced the slope in the opposite direction. I could have gone -2 and then forward 3. 1, 2, 3, and been right here. Either way would have done. It doesn't matter as long as I know that one of them has to be the opposite direction, either the 2 or the 3. I chose this top one. I'm not even going to darken this line, because this dot, because I don't want to try to figure out what the label is. I just used it as an example. Now I have to label my points. So I know that this point, x is 0 because it's the y-intercept, and I'm at 4/3. And I just have to figure out, where am I on this point? Well, the backward part is easy, because from 0 on the x-axis I went backward 3. Phew, that was easy. But the up part might be a little bit harder. But really not so much, because I know I'm 1/3 above the line. So I've gone 1, 2, well, let's go 3, 6, 9, 10/3. So that's 3 and 10/3. And now all I have to do is sketch in my line. I have this handy tool that lets me do this, and the reason I do, I'll show you in just a second. Rather than hand sketch it, you don't have to use a ruler or anything. The problem for me is when I try to make a straight line, or when I try to make a line, which is all lines are straight, with my tool. Well, of course it had to work then. When I try to make a line, it doesn't actually come out straight. Even if I sketch it in the right place with my hand using the electronic pen, it doesn't come out straight. I get this bubble in it. And so for me, for the lesson, it's easier to give you a line to work with. Okay, there you go. That's everything you need to know about graphing using slope-intercept form.